Chattanooga, boy had a dollar and a dime. Headed out for Nashville on the Hard Rock Line. I'm working on that old steamboat and learned to ride and steer. When my feet had touched dry land, how happy I did feel. Been saving every penny for to make up through the fall. Working for that dollar, but it never adds up at all. Coming around the riverbank, heard the old train whistle sang. The very next thing you hear from me, I've been tied to a ball and chain. Well, come this time tomorrow, reckon I don't know where I'll be. But if it wasn't for that old sheriff, I'd be back in Tennessee. Playing cards and crap games, not looking for the score. But if I ever get back home again, I'll never roam no more. Gather round your good time, boys, listen to my song. May not know better, but I know you know right from wrong. Buy yourself a postcard so you can see the lights of town. Find yourself a country girl, keep quiet and settle down.
And we're live. Just go ahead and music. Okay, there we go. So, yeah, today I'm gonna be hopefully doing the last bit of work on the physics rework. Mainly sorting out the issue of what kind of mesh collider to use for what entity, and I think I've come up with a good way of kind of handling that. Basically, I'm going to be copying the way Unreal does it by default, which is to not use one or the other, but use both. Basically, simple and complex mesh colliders for any given mesh. And the simple one would be the convex collider, and that would be used for collision detection by default. And then you'd have a complex collider, which would be the triangle mesh, which we would be using for things like scene queries, raycasts, that kind of stuff. At least by default. And I think this is going to be quite a good system. And you'll obviously be able to set, much like you can do in Unreal, like use complex as simple, which means the triangle mesh will be used for collision detection. And the reason why we kind of have to do that is if an actor has a triangle mesh collider and it's a simulation shape, meaning like you can apply forces and that kind of stuff, well, then you can't. Basically, triangle meshes, if you look, triangle mesh, height field, and plane geometries are not supported for simulation shape that are attached to dynamic actors, unless the dynamic actors are configured to be kinematic, right? And they can't be used as trigger shapes either. So that basically implies a restriction on what you can do when using the complex collider as a simple collider, meaning for collision. Now the question is, how do we kind of go about doing that? Because it's going to involve changing up the entire kind of cooking system and the mesh cache as well, significantly. So we can't just store single mesh, we have to store two meshes. One for the convex and one for the triangle. And the same thing goes for shapes. For, let's see, physics shapes here. We have to have both a triangle mesh shape and a convex mesh shape attached. We're gonna start with the cooking factory to kind of get it so we cook both a triangle and a convex mesh. And I've already kind of refactored this a little bit yesterday by making it so that these actual cook convex mesh and cook triangle mesh functions, they don't care what the type of the mesh is anymore. They just take in the necessary data, which I think makes a lot more sense. So this whole code is going to change because we're no longer going to be doing that. But I'm just going to comment it out for now. So we don't care if it's a static or a dynamic mesh. We simply care about doing this. Say cook simple mesh, and then a triangle mesh. That's all we care. Now, of course, the problem is we need to serialize these. So I may have to end up splitting this whole function into a different function, right? That takes in, because we essentially have to run this entire code for both of these calls. Now, I think, yeah, I added a mesh collider type to the collider asset. That's no longer going to be the case. And I think collider mesh is just the actual mesh itself, not the collider mesh, or rather the collider at all. So let's bring this one in here. Okay, so get this. Let's add a. Yeah, I can get rid of these two functions because they're kind of, well, they don't fully work all the time, and we don't really need to validate if it's a valid convex or triangle mesh. We're just gonna assume that they are, and if not, we just don't generate that particular collider. So what's this function gonna do? Well, it's going to be responsible for retrieving a mesh. It's gonna get a mesh data. It will, I mean, this is really just responsible for serialization and deserialization, right? That's actually all it's gonna do, because we're gonna be cooking these and then, based on the result, either serialize it or do nothing. What's up, Daniel? Alright, so this is probably gonna be serialize or D. How's it going? It's going good. I've finally come up with a good solution for dealing with this whole mesh colliders situation, and basically I'm just gonna steal Unreal's solution, because they actually have one of the best ways of handling this, I think. Don't like the name of the function, but whatever. What do we do if we deserialize it though? Just write it into the mesh data. Okay. I think we're gonna have two functions instead. Serialize mesh collider, and that's gonna be a void, and we're gonna have this, which will return a mesh collider data, which will be deserialized mesh collider. Just gonna move over the code, and then I can start adding the parameters, because that's a bit easier. So the serialization is really just this, right? And here we have the deserialization. What happens if the file doesn't exist though? Oh no, if the file doesn't exist, we generate it. Right, so we need to take in mesh data. We need to know the file path. And here we can actually fail, so in this case, but that's the only time we will actually fail, so maybe have this return a boolean and take in the mesh collider data. I kind of have to take in a reference though. Where am I? Here we are. Yeah, it needs to take it in as a reference because we may end up clearing the mesh data. So not const reference. And a file path. Okay. Right. This is gonna have to change as well. Because we kind of have to make this take in a list of mesh data. Or like a... Well, basically it has to be able to hold 2 instances of mesh data. But to be honest, I don't think this is kind of the responsibility of the serialization function. This is still gonna be done up here. Okay. Now the deserialize will also need a file path. And this actually allocates the mesh data. Do we want that? Well, hang on, no, wait. Yeah, because this would insert it if it doesn't exist. Which... Do we need this to return it? I don't think so. Because we don't do anything with it after we're done. So this doesn't actually need to return it. Now it needs to take in glider. Which... Well, okay, so if invalidate old or doesn't exist, we're actually gonna need 2 file paths. So okay, what I'm gonna do is split this up. So we're gonna say this is gonna be the base file name, and it won't have an extension. So we do that. Simple mesh, simple collider. What path? What extension? I use HMC. Yeah, so that's what we want. And we'll also have one for the complex. Now what we could in reality do is just serialize both colliders into one file. But for simplicity, I'm just gonna do 2 files. This one's gonna be for the simple one. So if we invalidate old or we don't have a simple one, we will go ahead and generate one. So that's this one. And if we successfully cook that one, we will go ahead and serialize it. Simple. Takes in the mesh data. Yeah, exactly. That's correct. This returns false if we can't write it. If that and that. Well, no. Split them up. Don't really like additional branching, but well, I think it's fine because this prints an error if it fails. So, and also return true here. Yeah, so it's fine. We can definitely go ahead and do this. San caffeine. Caffeine, sorry. Thanks for following. So if it's success and we get that, then we go ahead and add it to the cache. We're gonna rewrite this a bit eventually. And otherwise we want to deserialize the mesh collider. Now, I actually think this should return it because, yeah, So what I'm gonna do is up here, I'm gonna have a simple mesh collider data. And I'm gonna change this up quite a bit. And we're also gonna have a complex mesh collider data. This is now gonna return the mesh collider data and not insert it to the map immediately. So it won't be doing that. Okay, good. So let's take a look at the mesh cache now. We won't have this anymore. Instead, we're probably gonna have a struct. Call it cached collider data, cached collider. Basically, this struct is gonna hold 2 instances of mesh collider data. Is the point. Yeah. Mesh collider data, simple collider data, complex collider data. We may have to update these as well. In fact, I think we're gonna have to do that. Okay. Because then inside of here, we're gonna go ahead and create this collider data. We can actually just do this because it should have been allocated already. Yeah, I'm much more happy with that. This code is going to be added to the end of this function. Technically means we don't actually even need this if statement. Well, we sort of do. What I'm just gonna go ahead and do is say if we can't serialize it, I'm actually gonna change the result of this. So we're gonna have a result. Well, if you fail to cook the simple one, should we still continue with cooking the complex one? If the simple one fails, we could just say, okay, well, go ahead and cook the complex one, and if that succeeds, use that as simple. Potentially. For now, I'm just gonna go ahead and say if this fails, set result equal to failure. Also, we should probably do some data validation at some point, but won't bother with that for now. So that, we can actually go ahead and move this up here, because these are going to be used for the complex one as well. assuming we're doing invalidation or they don't exist. So that literally becomes this. Right? And we'll do cook or cook or load simple collider mesh. And then we just do this for the complex one. Oh. Triangle mesh. Cool. And to be honest, we may as well do this. No. I'm gonna say if we fail to cook the simple one, for now, we're just gonna abort and do a little fail to cook simple collider mesh, aborting. I mean, if we fail to cook the complex one, that doesn't really matter because it's not used for collision, it's only used for ray casting. So we can print a little warning here instead. Using simple for everything. And we don't return a failure. Do you have twin brother? No, I don't have any brothers. I have a sister, but not a twin brother, no. Do I look like someone you know or something? This is gonna equal collider data. Why do we serialize this again? Oh, it was back when we were setting the type. Yeah, that's not necessary anymore. So we just go ahead and add it to the cache. I saw someone who exactly looks like you several days ago. That's... I have a double ganger apparently. Yeah, no, I don't have any twin brothers, so... Must have been a double ganger. Right, generate debug mesh. We should generate one for both the complex and the simple collider. So this is gonna have to change as well. Currently it just takes in the collider asset, which, why does it do that? So it can get, right, does this. could just give it the mesh collider data instead, which I think makes a lot more sense. Collider data. So, we don't really use this for anything. Matt Blue X, thank you for following. So if collider data type is a triangle, we do not that. Oh wait, yeah, because we need to know the collider asset to add it. We can probably take that in as well in that case. And why do we need to know that? Because we do this. Yeah, I think this is gonna have to change a bit as well. Well, because adding... It's the mesh and then that, but the thing is we're gonna have multiple debug meshes. We're gonna have 2 per mesh. Jumping in code gober, yes. This is actually the second time I'm rewriting this whole system again. Okay. This will take in the collider asset. That should now be happy, although it won't work. So collider asset and right. Let's do here. Second time rewriting the system, but have you ever rewritten the engine for the 10th time? I mean, I've been rewriting parts of Hazel for like forever. I rewrote the scripting engine twice. This is I think it's the 3rd time I'm kind of refactoring / rewriting the entire physics engine. And I've been like rewriting projects constantly since I started programming because I was never happy. But I think that's not necessarily a bad thing either. Collider data. Yep. And it's the simple collider data. Down here we do complex collider data. Which, yep, and then we add the collider data to the cache. Okay, I think the cooking is finished now, so let's go ahead and fix up the debug mesh stuff. My Vulkan abstraction is like 90% done, as in really done, I hope. I got all the core functionality, etc. Yeah, it can definitely take some time to get the base Vulkan abstraction done, because there's a lot to abstract. But, well, there's not a lot to abstract necessarily, but there's quite a lot of stuff to kind of put in there. So everything else would be more alternatives to allocators, some optimization, ray tracing, etc. Yeah. Vulkan shutters. Yeah. I've sort of started to understand some Vulkan stuff just by like using Hazel and looking at the code, but I'm still just like, no. So, is there a reason why we use mesh for convex debug meshes, but static mesh here? Because in the end, they're both mesh sources. No. So we don't have materials. This one takes in what? They're identical. They're literally just mesh source. I finished Vulkan tutorial, was rendering a 3D scene and had no idea how it all works. Took me additional 2 months to sort of figure out how to do things in Vulkan. Yeah, Vulkan definitely takes quite some time to learn, from what I understand. So, there is no point in differentiating between this and this in the case of a debug mesh, from what I understand. Unless there's a difference in rendering them. There is, because we do use the submesh index here, but that yeah, there may actually be a difference because we only want to render part of the debug mesh. But doesn't that mean that in this constructor, like what does this do passing an empty? Just sets them, it goes through the and copies all. Okay, so it uses all of them. And then in here we just tell it which one we want to render for this collider. Again, I'm not sure if that's how we want this to work, but let's go with that for now. Keep it kind of the same. Right? Even though it kind of won't work exactly how it used to. So let's continue with that. But I mean, in that case, it's fine because we won't have to change anything in here. We just use both of these depending on which collider. So I don't actually have to update anything in here. Cool, I'm happy with that. Okay, now we do have some problems up here. This will return cached collider data. Like that. Which is bound to cause a bunch of issues everywhere. Well, no, just in here, I think. Yeah, because we actually... No. Ah, I see. Here we actually have to do kind of both. We have to render both this one and this one, kind of on top of each other. probably want to use different colors and stuff like that. For now, I'm just gonna render the simple one. Same thing here. Just render the simple one for now. Okay, let's go ahead and build, see what we get. Okay. Physics shapes, yeah. So this is a convex mesh shape. We're gonna have to update shape sharing as well. But I think for now I'm not gonna be focusing on that at all. So we need to get the cache collider data. And then mesh data equals collider data. This is the convex one, so it's simple collider data. And here we want the complex collider data. And I think for now, I'm just gonna comment this out. Because we won't really, I don't think shape sharing will work just yet. Now the difference is, this one most likely will only ever be well, it's not gonna be a simulation shape, or one, at least not most of the time. So false, and we'll just leave a little to do. Allow user to change this. Now, what other flags do we have? We have scene query shape. Which is what we want. True, and I'm just gonna explicitly do trigger shape to false as well. But this is kind of gonna depend on if you want to use the complex shape as a simple one, so use it for collision. And that means we're gonna want set this to false here. Okay, cool. We're gonna be adding both shapes here. Most likely. So add, create, and add simple collider, which, yeah, we'll just do this. If it's, well, this won't really matter anymore because the triangle mesh shape won't be a simulation shape. That's not important. Well, it will be eventually, but not right now. If this, we do that. Complex collider. Okay. Type no longer a thing. Okay, right. This whole editor is gonna change quite a bit with this new system, because we're gonna need settings for both the complex and the simple one. So I'll just render all options at all times, and to do only for complex collider and only for simple collider. Right. We're gonna have simple collider info. We'll have the type collider data simple dot submeshes. We'll do a separator. I haven't seen a Hazel Vulkan implementation though, so I can't comment on that, but I think it's a bit closer to an OpenGL abstraction, at least from the snippets I've seen, and it makes sense considering Hazel was originally using OpenGL. Yeah, it is a bit more similar to OpenGL compared to what like most Vulkan abstractions are. Obviously, it's like not a one-to-one abstraction because that's not a feasible option, but it is quite a bit more similar compared to most abstractions, I think. Where's this? Deserialization, which we don't have. Well, we don't have type anymore. So do this. Get rid of a bit of branching, which is always nice. There's no way this is gonna work first try, by the way. Collider type, no longer important. But I think it's gonna be quite a bit better when we actually have this working. Okay. Let's go ahead and quickly clear the hash. And let's give it a go. Hopefully this just magically works. You'd think I'd be good enough to make those kind of simple changes without causing crashes. Wait. Oh no, this is fine. It's just I had a leftover breakpoint there as well. What's up? It just did the simple one. Why? Okay. Cooking factory. Why would it only do the simple glider? This not the case? Which one do you think is better, physics or bullet? Honestly, it really depends on. Bullet's quite a decent physics system, or physics engine. But physics is kind of the industry standard, and it from what I can tell, it does provide some better tooling. Like you have an actual debugger. Bullet is, from what I understand, quite well optimized for things like fast-moving objects. But physics is kind of just a generally speaking, quite a good physics API, and it does provide a lot of useful extensions as well. One thing I will say is I love the fact that Bullet supports things like soft body simulations and that kind of stuff out of the box. Yeah, Bullet docs are non-existing. They're trash. Physics actually has some pretty decent documentation nowadays. They used to kind of have terrible, but they're a lot better now. So what's up here? Oh. God. We weren't serializing it to the correct file. Personally, I prefer physics, but that's, because I've been working with it for quite a long time. Although it is incredibly frustrating that Physics 5 is not publicly available. Main things to hate physics though is the building and the forced threading model. I don't mind building physics. It's super simple, at least on Windows. I haven't tried building it on Linux or Mac, but on Windows it's literally just install CMake, run a command, open up the Visual Studio solution that you get, build it. But the forced threading model is definitely a downside. Hey, we have all of these. We have the simple and the complex ones. Let's check the logs. That seems to have worked. I'm suspicious. Let's load the test scene here. Failed to cook convex mesh plane. Yeah, that's fine. So this one would have a triangle now, but that's completely fine because it's a plane. And we should still have gotten. We still got a simple for this one. Guessing it's just garbage. Yeah, it probably is. We should also handle that because it will still try and use the convex collider there. But if I hit simulate, we'll probably get a crash. Yep, exactly. And yeah, that's because we don't have any submeshes here. So we should definitely check that we actually have a simple collider inside of physics actor, I think. Yeah, so let's go in and grab this, and it's collider asset. We will do if collider data simple submeshes. Couldn't we check the, well, we'll want a better way of checking this, but for now I'm just gonna check the submesh size. But we're gonna have like a boolean or something like has simple or something like that. Complex. Also, one thing I will say about physics that I find annoying is you can see it says failed to cook convex mesh plane here. Well, if we go in here, where is it? We'll print that. Here, right? So this clearly fails. And we then set cooking result equal to this, and I would have expected result here to be like not success, like failure, and yet this result would be true at this point, would be a success at this point, which makes no sense at all. But yeah, either way, where was I? Here. Let's give it a go. But then again, I think all three of the named libraries are more than good enough for most people. Yeah, definitely. To be honest, I think in most cases it doesn't really matter which one you go with. They're all kind of capable of very much kind of the same things. I don't think Bullet has vehicle simulations, although I could be wrong. Physics does have vehicle simulations, but Bullet might have that as well. So you kind of have to look at, you know, the feature sets. There's no real way to tell which one is objectively the best, right? Because it depends on. So simulate. Hey. I think. Yeah, it works. Although it doesn't work for the plane right now. And all of these kind of mesh colliders have both a triangle and a convex collider. Now, I think, if I'm not mistaken, also gonna have to figure out. Yeah, for some reason this one's still using the triangle mesh collider as a, like, for collision, which I don't know why that is. That doesn't make any sense. So let's go ahead and open up the visual debugger. These are using the convex, but this one's using the triangle, which is strange. And you see, this is actually why, like, this is a very good way of kind of seeing why we don't want to use triangle mesh colliders for collision most of the time. Convex, it's like almost just a cube. Whereas if we use the triangle collider, it would be very detailed and cause extreme problems with the simulation. Well, not in the case of desks, but if you take the flower pots in the sponsor scene, they have so many vertices, and if they have a triangle collider and you collide with it, the performance of the simulation just tanks. Well, we can see we actually have two shapes here. We have convex and triangle mesh. Now, why does this one not use the convex one? It seems to be using the triangle collider. It has a convex one, and it has a triangle one. And this one has simulation, shape, and visualization. Whereas this one has scene query, shape, and visualization. So what's up? That doesn't make any sense. It shouldn't have this. Well, it shouldn't be used for collision. And the plane has a triangle mesh geometry. So obviously, if in the case of the plane, since it doesn't have a convex one, it should use the triangle one for collision. But this one shouldn't. So that makes no sense. Okay. Let's work on improving this a bit. The collider asset, we're gonna have a enum. And this enum will be used to determine which collider is used for what. So, okay, if I just, for now, we're gonna have like default, which will be use simple for collision and complex for scene queries. Then we're gonna have use simple as complex, I think. Well, the most important one is use complex as simple. And this will use the complex for collision and scene queries, right? We may want one that lets you use the simple one for scene queries as well, which would basically mean you don't have a complex collider. And we're gonna be checking this in the cooking function as well. Question is, what do we call it? I hate coming up with names for these kinds of things. This describes what colliders when to use what collider where. Could call it collider flags, and we could actually like move some of these in here as well. Collider usage. I actually like collider usage. I don't think we need flag because it's not technically like, you're not going to be able to OR these together. You're going to have either one or the other. Collider usage. Yeah, we'll call it that for now. Thank you for that, Rocky Dev. I'm gonna add use simple as complex. Use simple for collision and scene queries. I'm gonna have that in there just in case. And we'll make this a, I don't know, 8-bit unsigned integer. It's fine. I don't want to name it. Let's just do usage. Well, yeah. No, I'm gonna name this flag because I want to name the variable collider usage. And even though on MSVC you can have the type and the actual name of the variable be the same, that is only on MSVC. You cannot have that on most other compilers by default, I don't think. And I want to try and be a bit good about it. So, in Cooking Factory, what we can say is if question is, do we still want to cook a simple mesh if we're never gonna use it? And I think the answer to that is no. Although that does mean you won't be able to use it as a trigger either. Oh, okay. What I'm gonna do is I'm gonna leave this. We're always gonna cook a simple one because that is kind of required if we want to support triggers. Even when you use a complex collider for collision detection, you may still want to have it as a trigger, and triangle mesh colliders cannot be triggers. If you, however, specify use simple as complex, we don't need to generate this at all. Okay? Because in that case, you will never need this. So, if collider asset is use, if it's not, use simple as complex. We want to cook this. Yeah, I like that. That also means that in generate debug mesh, I'm gonna have to check if this is the case and collider asset usage is not use simple as complex. Because if we're doing this, we don't need to generate a debug mesh either. Okay. Then that means we can actually update this. Because if, let's see. Again, we kind of always want to do this if we can. We might not always be able to because we may not actually be able to generate one of these like we can't for the plane. But if, okay. Maybe if this flag is set, we never add this. But that would again not allow us to have triggers. So I'm gonna keep this the same. And here we will only do this if, first of all, we have the data. And the usage is not use simple as complex. Yeah, that's much better. In here we could also make it so that if this one fails, we just set the flag to be use complex as simple. At least if this is set, but I'm okay with returning failure for now. Then in physics shapes, in here, simulation shape. Right. If it's not a trigger, we want it to be true. But also if we are saying use complex as simple, we want this to be false. So if it's either a trigger or glider asset, use complex as simple. Right, so if it's either a trigger or we're using complex as simple, we do not want this to be a simulation shape. Trigger shape, that's fine no matter what. Scene query shape also depends on use simple as complex, right? Yeah, exactly. So in here, simulation shape will be this if use complex as simple is true. Wait. Yeah, exactly. Trigger shape will always be false, and scene query shape depends on what exactly. Because we want it to be a scene query if it's this or this. So if it's not this, yeah, that is correct, I think. Okay. Let's see if we can't fix up the debug rendering. Let's get this up here. And this is the simple debug mesh. Complex debug mesh. Cool. Let's give this a try. We currently can't change that flag, but you know, we're gonna have to work on that. Yeah. I still want to know why this one's using the triangle. Or maybe this is the... Might be because it's static. That shouldn't matter. Should still be using this as a simulation shape. So maybe this is actually the convex one. Yeah, I think it is. That's interesting. So this is the convex one, but it's not correct. That's weird. Oh yeah. Do these not have simple colliders? Or complex rather? We're not seeing the debug. Okay. Let's try rebuilding the glider cache. It's taking a while. Okay. Yeah, now we see both. Okay. Yeah, there's still some weird bug that doesn't generate the debug mesh all the time. Whoa. Frame drops. And I mean, you can definitely see, like, we're eventually gonna use it so that the two colliders have different colors. Looks cool. Thanks, Daniel. Yeah, I'm actually a lot more pleased with this. Now you can see obviously the collision mesh. The simple collision mesh doesn't quite look correct here. I'm actually wondering if... Yeah, that may just be... So okay, our debug mesh generation is not correct because this is what they're supposed to look like. So this is wrong. We may not be applying the scale of the entity or something. Well, we shouldn't have to because it's uniformly scaled. So definitely something not right there. Let's take a look and simulate, and that does take a while. Yeah. See, it kind of looks like... I'm gonna have to change the mode here to all. Let's take a look. Yeah. See, it looks like it's not quite using the simple one, even though in here it does look like it is. Also, why is it still falling through the floor? Oh, I know why. It's because I forgot to fix something. We need to, in the cooking factory, yeah, if this fails, let's do result, failure, because we do need to handle this, right? If we this is the case, or result is failure, we want to generate this instead of failing. Because in the case of the plane, it can't have a simple one, but it still needs a collision mesh, so we try and generate a complex glider shape. Now, if we fail to serialize this one, see, I kind of want to have two variables for holding the result here. Yeah, I'm gonna have to do that. Simple mesh result. And then down here, we'll also have a complex mesh result. So if we use simple as complex, or okay, let's say if we are using the simple as the complex and the simple mesh result is not equal to success. Wait, hang on. If we're not using it as complex, yeah, then we don't care about the result. Or we fail to cook it. Then we try and generate this. And we set this to failure. And if we successfully cooked it, we do that. If this is successful or this is successful, we want to add it to the cache. Yeah, how do we know what to return? Well, we can say if we get here, we return success. Otherwise, we can't just return failure. We may have to take these as kind of out parameters or as a tuple. But for now, I'll just return simple mesh result, because right now that's kind of the most important one. Well, technically no, but it's fine for now. So if either of these are successful, we want to cache it, but if the simple one fails, it may still have some data assigned in here. Actually, no, it shouldn't. It should not have any data whatsoever. Also, we should check the result here. Because we shouldn't serialize it if it's failed. And I believe if we check in here, if it fails, we do in fact clear all of the data out. Cool. I'm liking this a lot more now. Feels much better. Let's clear this. Okay. It'll be interesting to see if this works with forest. So you can see we failed to cook convex mesh plane, right? This should now have a triangle mesh that is... Ooh, actually, this won't be used as a simulation shape just yet, I don't think. Yeah, no, we're gonna have to update that as well. But it's closer to working. And it means we won't unnecessarily generate a garbage file for it either, which is good. So let's go ahead and get it set up so it's actually a simulation shape. What I can do, I think, is if this happens, but this succeeds, let's maybe do it in here. We can do if simple mesh result is not a success, but we are, then we need to tell the asset collider usage, use complex as simple, right? Now, if it's a physical asset, we do need to serialize it. Well, technically we don't have to, I don't think, but if is physical asset importer, serialize collider asset. So that means it should now use the triangle shape as a simulation shape and as a scene query shape. Clear the cache again and give it a go. Now the plane should no longer not be collidable. Which means we'll actually have quite a bit more of a robust system here. Which is going to be really helpful. Let's give it a go. Hey, it works. Nice. Now, our way of generating these convex collider debug meshes is incorrect, as we can see in here, because these, if we take a look, this is the convex, and this one's the triangle one, and the triangle one is, like you can see in here, the convex one is like the same size as the triangle collider, but our debug rendering does not show that, right? So this is incorrect. But I think first thing, I'm gonna update the triangle one to be a different color. Now this is by no means working 100%, but we should probably take care of fixing these things. So, and we're gonna have to add back shape sharing as well. That's gonna be super useful because it means we won't be copying the data multiple times. in scene, we do this. So this is the simple, this is the complex. How do we know which color to use here? I think inside of here we have a physics collider's color, which is used where? Here. We set the color there. So, and this is where exactly? In the initialization function. Okay. And we also do it in here. So static collider draw list. We want this to be a different color. We want to have simple and complex. This will be the complex. This will be simple. And we can, like, this doesn't really matter, but we'll just do simple for now. Now, what color should we use for the complex? Like maybe a blue one or an orange? I don't know. Let's just grab color picker. Well, let's do this. Here we have one in the green. Let's go 0.2 and then one in the blue. And I can probably do not a distribution build, release build. But we should more easily be able to differentiate them. I'm actually not looking forward to trying to fix the convex mesh, the convex debug mesh generation, because that involves understanding geometry. Ooh. Okay. That is due to the bug that doesn't generate the mesh collider, all the debug mesh collider, all the time. So let's just rebuild the collider cache. Good now. Well, they're still not blue, and I think that's due to instancing, probably. We may need to set up a new so that's because there's still if I understand this correctly, it's because we can't update the uniform in between these, which means it's gonna have to be a separate render pass. Maybe? Don't know rendering, so I'm assuming that's what we'll have to do. Or is it the pipeline that we have to change? No, I think it's the render pass. We have to begin a new render pass and then do the same thing, I suspect. So we'll do this. Then we end the render pause here. Then begin it again. Can I do that? I don't know, let's give it a go. Begin and end. Set this, and then render the other ones. And I'll have to rebuild cache again. Yeah, no, that still doesn't work. Well, that's annoying. I suspect it's the pipeline then. Okay, well, whatever. I'll leave it like this for now. And I'll have to have a word with Jan or Karim and have them explain it to me. Okay, well, let's take a look at that. Generation of debug stuff. So I basically stole this from Unreal, so let's take a look at their code. And I think it's this stuff. I'm gonna move it over to another monitor. So, grab the number of polygons, grab the vertices and the index buffer. Move through the polygons. Well, that looks correct. Could be the transform, maybe? No, I don't think so. Yeah. Why is this incorrect? So it seems like it's too small. That would make me think the transform is, incorrect. But I don't think it is. Submerged data, which is this. Which is literally just the transform of the submesh. Could it potentially be some of our flags that's causing the data to be generated incorrectly? Could it be this? Because I think it's working when we don't have to quantize the input. But for some reason, when we do this, it doesn't work anymore. I don't know. We could, instead of, well, I can't actually change the vertex limit either because it's maximum 255. I don't know, let's multiply that by 2, see if that works it. Because I definitely suspect it's the quantization of the input that's messing stuff up for us, which is annoying because we kind of need that. No, that's not fixing it either. Because you can see here it generates the convex mesh correctly. But for these desks, which have basically, they have too many vertices, supposedly, which doesn't make any sense. Okay, whatever. That's not super important right now. Let's revert this change. So I'm gonna track down the bug that basically makes it so we don't generate a debug collider in here. I think that's maybe a bit more interesting. And also it's a bit more kind of urgent, I think. The mesh collider not looking correct in Hazelnut is just a visual glitch, whereas this is an actual crash. So also, we shouldn't have to be cooking these again. Strictly speaking. Well, actually, yeah, we do, because they're probably memory-only assets. But that still shouldn't really be super important. So, this doesn't result in a crash anymore, but we still don't have the debug mesh. That means that inside of the serializer, when we are deserializing it, we are for some reason not getting the correct debug mesh generating. So I'm gonna put a breakpoint here, and we're gonna reload the scene. So this is one of the tables. That is correct. We'll try and get the asset. We don't have one. We have a static mesh component, so we create the collider asset. We then get it. And we don't do this. Which means it already exists, because of course it does, because I just reloaded the scene. This is so frustrating to have to debug. Okay. Now we put our breakpoint here. We go ahead and do this. Now, the cache should not have this particular mesh in it. And this is a table. So we hit this. And I think it's the triangle mesh collider that's not working. So grab the mesh. Yeah. That's correct. Yep. So we deserialize it. We seem to have... Yeah, okay, that type is not valid. So... Because... Now this is in fact convex 1, but the type is still not valid. It's at the 204. So this one is actually a fluke. Okay. So I know why this is happening now. It's because we're somehow... We get this. We set the type. And then we literally just dump it. So this is an unsigned 8-bit integer. I guess maybe it doesn't like the fact that it's the enum type here. maybe. So let's change that. Pass this to the actual value. And then when we deserialize it, we just read it in. And also we are never setting the actual type in here. Actually, that could be why. We were never reading the type back in. So I suspect that's it actually. So it was just set to garbage. Where do we have the... here. We didn't actually have to regenerate those, but let's do it either way. Don't need a breakpoint. We have both colliders, so we stop and restart. And now we have both. Good. Glad we fixed that bug. So I suppose I should go ahead and expose that collider usage flag so you can actually set it. And then maybe we start working on updating the Mesh Collider editor to work with this new system a bit better. Yeah, let's do that. So inside of scene hierarchy panel, so material is shared shape is trigger. Okay, let's see. We're gonna have to do this. It's not an asset handle. We can probably interpret it as its actual type. The underlying type is an unsigned 8-bit integer. So, and this is actually on the component, which is problem. Because we're gonna have to, yeah, we're gonna have to write this a bit differently. We're gonna have to get the asset, collider asset. I don't know, let's just do collider. Get asset, collider asset. No. That, and it's other, that, collider, collider usage, cast that down. Yeah, that's what we want. Let's pop it. Then property dropdown. We may as well use the enum one. Collider usage, whatever. Which one is it?
Hold up, wait a second. I need to know your title. Turn around, I need a minute. Are you anybody's wife yet? Keep holding my breath since the day you left. Can't get no rest. No, no. Deleted all your photos, but they're still burning inside my mind.
Enable cons chart pointer options, option count, and the selected one. We also need to give it an underlying type. Okay. Underlying type is unit 8T. That's kind of static. Cons chart pointer. Collider usage options. Alt. I use complex as simple. There we go. Do we have a reference to the asset? We do. And that can't be const anymore. Asset manager. Get asset. Asian leaflet. Thank you for following. Oh, hang on. Why did that get deleted? Damn Nightbot. Okay. Nightbot is a pain. It's way too aggressive. I'm gonna tweak that real quick. Because that did not look like spam. It's because, okay. So I would not actually count that as spam, but it's because of the infinite O's basically. So, spam protection, and that was, I think, excess symbols. Yeah, it is. And the limit's 8, so let's maybe increase that to 20. Okay. Sorry about that one. Still haven't quite tweaked Nightbot to behave the way I want it to. Collider. I don't know. Alright, seems my IntelliSense is having some problems. Collider asset. You good now? Okay, cool. Now we should probably cook the mesh if you change this, but well, maybe not. We'll have to do some testing. So, why is this disabled? Oh, I know why. Because we need to invert this. To be honest, I think I'm gonna go ahead and disable quite a few of the Nightbot spam protection filters, because they're just not really necessary right now. Okay. There we go. Now we can update this. So if I go use simple as complex, there's no real way for me to test this other than maybe having this one around there and see if the ball can roll under. Can I? No, I can't. Okay, because they've fallen asleep, I think. Let's try this. Yeah, it does seem to be working. If I go default, we get the same thing. However, if I do use complex as simple, we still get the same thing. Huh. Let's do this. So which one is it? I don't think... Oh, we're in release mode, so the debugger won't work. Let's try it on this one instead. Nope. Are we not disabling this one? Okay. So this is at the simulation shape if... Oh. Because this is false. Yeah, this isn't quite... Because if it is a trigger, even if we're doing this, we do want this to be false. But we don't want this to be true if this is the case, no matter what. Right? We'll maybe reverse the order. Because that way, if this is the case, we will always set this to false. But if this is, say, something else, but it's a trigger, still not sure this is correct, but isn't that the same thing? No, because it kind of right, because if this returns... Wait. I think this flag is incorrect. Yeah, that flag is actually incorrect. If it's not this... But yeah, no, this, it wouldn't have been the same thing either way, because if this kind of returns true, then this would never be checked. And because we had this first, if this statement returned true, we would never even check this, right? So the trigger would always override it. But I had my my comparison incorrect, I think, because if we are using the complex as a simple one, we want this to be false. So this should actually work now. Also, hello Bojozos. You're gonna have to teach me how to pronounce your name at some point, because I don't think I'm getting it right. But if it's not a trigger, it's still true. Well, so, I mean, I suspect this is not fully correct, but right now, if we are using complex as simple, right, this will always be false, right? Well, actually, no, this is correct. Hang on, is it? Or would they evaluate this? No, this would not be evaluated as a single statement, I don't think. Because it's an or. If it was an and, it would be. Right? So currently, this will be a simulation shape if our collider usage is not use complex as simple, which is correct. Or if we're not a trigger, right? So we start by checking this. If this returns false, which it would like most of the time, we then proceed to check this statement, which is exactly what we want, right? So this is actually correct now, I think. It should result in the behavior I want. And where is my... Alright, selected. I think, and I'm gonna do some, make sure I test this properly. Also, that did not save apparently. So if I set this to use complex as simple, this box should not fly off. Except it does. Why? Just... What? Okay, I'm gonna have to run this in debug and check the visual debugger to make sure that they're being set correctly. I may... It shouldn't be used as a simulation shape, meaning we shouldn't collide. Or have I got that completely incorrect? Do we still like collide even if it's not a simulation shape? No, we shouldn't. If it's a simulation shape, then we should collide, because for triggers you always disable... Hang on. No, I think it's sort of correct, but not quite, because it's in physics internal. In here, we check if they're triggers. In that case, we actually don't do a contact. I think it should be and, because it's not a trigger and a statement. No, it shouldn't be. Because the thing is, if it's a trigger, we want to disable simulation shape, right? But only wait. It's not a trigger, which means this would return true, but because this returns Yeah, no, it should probably be and, now that I think about it. Because this statement would return false. No? Yeah. This statement would return false for that table because it is this. Oh, why is this so hard for me to wrap my head around? So collider usage is in fact this, so this would return false, meaning we would go over here and check if it's a trigger. It's not, so it would be a simulation shape, meaning yes, it should be an AND. Yeah, that's correct. The only time we want it to be a simulation shape is if it's not using complex as simple and it's not a trigger. So, okay. Why was that so hard for me to wrap my head around? But either way, I don't think this is fully gonna work. Well, it might. It might actually work. Let's give it a go. Yeah, no, that's you're definitely right on that. So this, in theory, should work, assuming the filter shader works as it's supposed to. So let's check this one. We need to start serializing this. Use complex. Well, actually, yeah, this is gonna have to be a property of the mesh collider at some point. Use complex as simple. Yeah, it doesn't go flying off. Now it, for some reason, doesn't seem to fall either, which is interesting. Why isn't this going? Because I disabled gravity for it. That's why. So if I move this down, it does in fact not collide, because it's using the exact mesh that we see here. If I do use simple as complex, it does go flying. Okay. If I set this to be a trigger, then it doesn't. So yeah, that's absolutely correct. Thank you for helping me wrap my head around that. Don't know why that was so difficult. But yeah, so the mesh collider is also gonna need one of these. Because if the asset is a memory only asset, then we need to save this in the actual mesh collider component. Meaning we need to modify this to be... We don't need those. Well, yeah, we don't. We can simplify this quite a bit. I'll keep it on multiple lines. What's up, Eddie? How's things? We want other... No, we want first component collider usage. Here we need to do this dot collider usage. And if this has a valid collider, this cannot be const reference. We set it equal to this. That is now correct. Then in serializer, where are we deserializing? Up here. Oh, serializing, sorry. Yeah, here. Collider usage. I'm probably gonna end up renaming that because it's not super accurate. We need to cast this to an 8-bit integer. Zero will be the default, and then we'll just cast it to that. Okay, that's correct. Do I need to update it anywhere else? Because we do update it in the collider here. So that should work just fine. Now, I still don't think physical assets are actually... Oh. Does it not know what that type is? Yeah, I'm guessing it doesn't know collider users flag. Under asset. Yep. So now it should know what the type is. And I hate it when you have to modify the components header file because it takes forever to rebuild. There we go. So if I set this to use complex as simple, we save the scene, we load new village, we load back to test. That is saved. Let's make sure it works. It does. Yeah, it works. Okay, good. We have exposed that. So what else do we have to update? We have to update the mesh collider editor now. I'm wondering if we should split these into sections. One thing we definitely need is under collider settings, we're gonna need that drop down. I'm gonna have a look at what Unreal calls this at some point, because I don't think collider usage is strictly the best name to describe it, at least not to the user. Collision complexity. Yeah, that sounds familiar. Mind78, hello, I am also from a small town in northern Sweden, work as a game dev. That's awesome to hear, man. Okay, and let's check this ban real quick. Where do we have the ban? Cool. That's also mine. Do you, I'm assuming you kind of work remotely, because from my experience there's not a lot of game dev jobs kind of in northern Sweden. Tab data, collider asset. You're not living up there right now, but you're born and raised there. Okay. Yeah, that tends to be what you have to do as a game dev here. Like, you almost always have to move to either Gothenburg or Stockholm, or, you know, work remotely. So, let's check here. Probably gonna divide these into 2 sections. We're gonna have the complex properties, and we could do property grid header, say simple collider settings, and have them be open by default. But we don't want to render this one if we are using the complex as simple. Right? So if it's not use complex as simple, we're gonna have if do this as an and. If it's not use simple as complex, complex collider settings. Vertex welding, I think, applies to all types of colliders. Let's do a fine on that one. Well, so it applies them as kind of global parameter, but I don't know if they're used by both types of colliders. Also mine, thanks for following. Forgot to mention that one. Now my microphone's gonna cut out because I'm gonna open this. No, it's not, because we actually get a crash. Because I probably forgot. Yeah, I forgot to do tree pop on this second one. And immediately I can tell we need to split the property grid. So we'll have that one in here. And in there. Now there is another thing, which is if the asset sets this flag, that should be copied across to the component in here. So, and we should probably do this instead of only if it's true. Yeah. Cool. I think we're actually kind of close to being done with this, like the whole physics refactoring. I obviously need to do quite a bit of testing to verify that everything works, and to make sure that the old projects still work. Close that, and I think this one is using that. Now, actually I forgot to do one thing. Well, I've forgotten to do a couple of things. First of all, in here, we need going to save and add mesh collider, collider usage, type data, collider asset, collider usage. Then I need to check in asset serializer. We need to in fact serialize the collider usage. Now I think it's correct. believe this one has now received the updated flag. So if I move that there and we enable gravity, yeah, that works. Awesome. Now I think in this case, if you're using an asset, things like shape sharing and collider usage should be fully controlled by the asset, not per instance. Because that's gonna let us, we kind of have to do that. Because if we don't, then shape sharing won't quite function properly. And I should probably work on actually getting shape sharing working again. So in here, do we have a way of checking in here if it's no? We're gonna have to do an asset manager is memory asset. Do a const bool is physical asset, because if it is a physical asset, then so if we have one and we also see this is sort of already done for this, but I think this isn't quite what we want. If we have one and it is a physical asset, we want to disable this. For, let's see, this, we want to do begin disabled if we have a collider asset and it is a physical asset. Because then it should be controlled completely by the asset itself. So if we check this one, we can no longer explicitly set these for this instance. And if I go in, we see that that gets updated. And I have to remember not to talk when I have a mesh collider open, since my microphone cuts off. Okay. Let's go into physics shapes and work on this. Because we can't just have one shape, we need basically two shapes. Actually, no, we don't. We definitely don't. Because we have two different maps. So it's fine. Yeah. This should just work. Now, I still think shape sharing is not 100%, but it's probably like 90% there. Let's just verify that this actually works. It should, but you know, always best to make sure. So, if I take this one which has both of those set and I duplicate it, we move it over there, and we duplicate this one and move it over there. That works. If we move the rotation, if we move both of them up, okay, so that's not correct. What happens if I move this one over to the edge? Let's just check. Use complex as simple. Yeah? Are we getting any physics? No? See, this to me does not look correct. So I guess time to launch it in debug mode. And see what we get. Not even sure if debug mode will work. I mean, I can check that box because it's that part of it is done for the most part. I'm just gonna go ahead and add different color. Are you going to use the new C++ modules or keep going with headers? We are most likely not going to be updating to C++ 20, which has modules, at least not for a long time. I don't think anyone wants to go through Hazel and convert it to use modules, because it would be a painful experience, and it would take forever, and it's probably not worth it in the end, in terms of in terms of time spent on it. We may end up updating to C++ 20, but we're probably not going to use modules. At least not convert the old engine, like the old parts of the engine, to use modules. So let's bring this one over to that monitor. Wait, what? It works? Okay. There we go. Invalid parameter in attached shape must be shared or unknown. Huh? What is this? So which one is this? Okay. So this is the table that doesn't have an asset. because that's true. Did we not clear this? Well, this is annoying. Ladder mesh is what exactly? 1194, which we do have. Shape must be shared or unknown, which means this one is set to be exclusive. This was working before. C++ modules today still have a bad support. They work fine in Visual Studio with MSVC, but with Ninja and Clang they don't work yet. Yeah, I've heard that before. Seems like modules still aren't super stable, which is just another reason not to use them yet. Even though like we mostly target MSVC, generally speaking, good to not use unfinished systems. Okay, now these have used shared shapes, so these should use these should technically use all of the same, except that won't work because of the collider usage parameter. We're gonna need to take that into account as well. So I think that's actually what's going on here. I have a feeling if I disable these and hit simulate and we release that breakpoint, we don't get a crash, and this seems to work. What if I bring them back down? Do we still get that? Okay, works. So yeah, we're gonna have to account for the collider usage as well, because that's currently not... I have a feeling if I go ahead and enable this and set this one to default, and I hit play, works, but then we get a crash. Yeah. So yeah, I'm gonna have to rewrite this a bit. Let's try release mode here and check if that weird collision issue still happens. So take collider usage into account. when using shared shapes. So that those both have that. If I disable that, seems to be working fine now. Yeah. So that was seemingly just a strange bug, maybe. So take letter usage into account when using shared shapes. How are we going to do that? I think if we have like a struct here, shared shape data, it will hold the collider mesh handle, and we'll also have to hold the type, the collider usage flag. We could do this. Actually, I think the triangle meshes do this a bit differently. No, they don't. So we can actually move this entire map into here. Call it shapes. We would store this, and we would try and find a version of this in the map that corresponds to the data we have. If we can't find one, we'll have to create one. I'm gonna add a little so if we find this, that doesn't really matter if we don't have a valid one. So actually let's store, I'm gonna store pointers here, which I know, ooh, scary bad, but I want to be able to return null pointer. Shared shape data, find suitable shared shape data, which will take in the component and we can just say immediately if we kind of need to know the map as well. If find, we're gonna need to get the collider asset. So if collider asset collider mesh is equal to shape map.end, shape map, that means it doesn't exist, and so there is no suitable one. And then we need to iterate, right? Through well, now if we have this needs to be a vector. Because we could have multiple versions. So now we need to iterate through all of these. Oh. Forgot to update this. Okay. If shape data usage is equal to provider asset usage, and currently we only have this one, return shape data. In the future we may want to take other variables into account here as well, but for now it's just the usage. So in here we want to grab if use shared shape and shared data is not equal to null pointer, and we want to give it the shared convex shapes math. Then we need to iterate through the shapes and attach all of those. If we don't find a suitable one, we need to go in and create one. Do that. We then need, hang on. Right, okay, so this is interesting. If we find this, we may not have the correct submesh index. So we also kind of have to take that into account. Because in the case of a convex mesh collider, we actually have one of these for every submesh index. Well, no, for convex mesh colliders we would do this probably. Because we would have one component for each convex mesh shape. Meaning each of these would actually be unique. Which arguably is not good for memory usage. And it very much isn't. So we look for this, then we need to check, is it the correct usage? Rather, if it's not the correct usage, continue. We should probably come up with like a scoring system here. Well, no, we don't need to. I'm gonna do something a little bit ugly. Actually, find one with the correct usage. It may or may not have the correct submesh stored in there though. So if we use shared shape and shared data is not equal to null pointer, and we have the correct submesh, we do that. If we don't have the correct submesh, we still need to come in here. So what we can do is say if, what did I call it? I called it shared data. If shared data is not equal to null pointer, it means we found an appropriate one, but we didn't have the correct submesh. Alright, so found suitable shared data, but our submesh doesn't exist in it. At which point we need to do shared data shapes that. Otherwise we need to create a new one. So we actually need to do a new one here. And we don't need to do an equals, we need to do a pushback. This is a vector, so don't even try. Fail to find suitable shape data. Create a new one. Okay, I'm liking that. Now this is going to be a little bit different for the triangle mesh, I think. So, because a triangle mesh stores all of their submeshes immediately. Meaning here we actually just need to check if we find one. Because if we find a suitable one, then it will have all of the appropriate shapes. Most likely. May or may not be true. So if we get here, we need to do h new. No. In here we still need to check if shared data is not null pointer, because this is in a loop. It's literally the submerge index. Good. And we add it here. Otherwise, we do that. Yeah, that's correct. Now it becomes a bit more interesting in here. So we get that, we try and find. Here we should use we should still try and find suitable here. We need to do we don't want to clear it yet. We need to remove this instance from the vector, is what we need to do. So let's do shared shape vector. We need to do erase. We need to remove there. And then call hdelete on it. Remove it from the vector, delete it. Pretty sure that's true. Now, if the vector is, do we have an empty? Yeah, we do. If it's empty, then we actually want to call erase and actually get rid of the vector completely. Okay. to do the same thing here, but for convex shapes. I think this is gonna work. Okay, so I'm probably not gonna be able to get all of this done today, but I think I'm pretty close to being done with it. I'm gonna have to end the stream in like 20 minutes. So, if I set these to use a shared shape, this should still work. Not quite. Something's still not working correctly. But it doesn't crash, which is... well, it probably would crash if I was in debug mode. One indication we can check to see if we're actually deleting these pointers correctly would be by checking the memory profiler in here. And we can search for shared, well, let's just see they're shared, if they're shared. Hit simulate and let's check out might be the physics shapes one. Yeah. 288 bytes. Okay, so it's still 288 bytes. That doesn't seem to be changing. Might be one of these nulls. Because they're static, so they don't technically belong to anything. Does this have a way? Also, it's file. So it uses the file. Okay. Not correct. Which one is this? It's this one. The size, file, and line. Meaning it should technically give us a physics shapes line 477, right? Except it only seems to display the total. Yeah, you see, I don't think that's correct. No, it shouldn't be that. It should be convex mesh shape. It does seem to be cleaning it up, but we're still getting that weird behavior, so let's run in debug mode. And I have a feeling it's just getting the wrong one. So let's start by taking a look in here. These two uh, 46 and 49, yeah. Which is exactly what this should be using as well, 46 and 49, that's correct. These two are using 28 and 31, and this one should use that as well. Okay, so on the first go around, they use the correct shared shapes, which is good. So I have a feeling it's just the cleanup that isn't working. Because on the first, whoa, okay, that was weird. Camera just flew up off into the distance. Now I think I'm gonna get a crash. Exactly. And that's because we are not cleaning up the shape correctly. So it does find one, but the shape is not valid anymore. And if we look under where is it? Because this does look empty. Okay. I'll put a breakpoint in here. And in here. No, thank you. First of all, yeah, okay, that worked. I'm gonna be so happy when we're done with this. First of all, it's so much more flexible and stable, and I won't have to bother debugging it all the time. I join again and see a black white screen. Yeah, you're about to see a crash pretty soon, so have fun with that. First go around should work just fine. It does. I'm sorry. What? We don't do any cleanup? What? Or does reference count never hit 1? Okay, hang on. What is happening here? That should not be happening. Well, it should be. Like, we should be detaching. So, what's up? I swear this used to work. Or are we not finding the correct shape? That could be it. For some reason, we may not be finding the correct shape. And we do this. Okay, so we are in fact detaching. Let's see, which component is this? It's, that should not be happening in IC stage 1 denial. Yes. So this one is not using a shared shape. So it's most likely the plane in that case. Okay, that makes sense. Which is backed up by it having a reference count of 1. Very much accurate. It only has one shape, yes. If you look, the collider acid is 6004. And if we look in here, that does not exist, which is correct. So this one should just be fine. We grab this, nothing happens. We get a null, so we don't do anything. Correct. Now, I'm guessing this is the same one. This is the plane. As well. Yes. It is. So again, get nothing. Now, 10508. Which does exist. Or does it? No. Which one's this? Oh, we may not have reference count 2. But it doesn't exist. Yeah, that's... Okay, so is it just we're not adding all... Wait, no. No, I'm dumb. It may still exist in this map, because we index by mesh. So we skip that. Should be the same here. We get 2. We skip. Now. 2. Something seems a bit fishy here. Let's maybe do this instead. Because if I'm correct, we should hit these breakpoints twice. For like each one. So we hit this one. We grab the collider asset, we check once. That's not correct. Okay, something's horribly broken. Something is very, very broken. I think it's with the creation. So let's first of all put a breakpoint there. Put a breakpoint there. This is why I hate debugging. And I'm gonna have to end the stream pretty soon. make some dinner. But I want to see if I can at least figure out what's going on here first. Hit simulate. We get this one. Shared data is null, which it should be. We come down here. We allocate a new one. This is the default, so it's one of the memory-only assets, which is, correct. And collider mesh is what? This. Just gonna keep track of the data. And it's 1194. It's what it starts with. So we hit this. We come, which one is this? Okay, so this is the triangle mesh, and it's the first one. But so I think this is the exact same one. It is. So this is the complex one. We add that. And this is the convex one. Their data is still null pointer, because we use complex as simple, so even though it's the same collider mesh, it's a different one. Wait, hang on, which one's this? Collider usage is that, okay. We don't have that one, so we create it. Same thing for the triangle shape. Yeah. Now we should start hitting these. Okay, let's take a look in here now. This one now has 2 of these, each with 1 shape, meaning the creation is actually correct. And it has to either be that the asset handles change somehow. Wait, hang on. Should this be happening? I think so. Yep, and it's the default one, meaning this one is using the correct one. And yeah, it should happen. Now I'm worried that this shouldn't be happening twice. This would go and create the shared shape, 2 shared shapes, and this one should simply use them. Okay? meaning we should only get... But then we would have the same thing for these, yeah. And we do have 2 entries, which is in fact correct. Okay. Good. So put a breakpoint there. And put a breakpoint here. We stop simulating. Let's take a look in here. Size of 1 and size of 2. Yeah, that's correct. Let's take a look in here. This is the plane. And we don't find it, which is correct. This should also be the plane. Which is correct. Now we should hit the actual tables. Reference count of 2. We detach it, meaning reference count will go down to 1 the next time. So we ignore it and we clear our shapes. The same thing should be true here, which it is. We hit this. It's still 2, meaning this is the other set of tables. Where is it? Yeah, it is. This is the other set of tables. And so we remove them. Same thing here. Now, we should only have 2 tables left to detach from. But why don't we hit the convex one, is the question here. Reference count is 1. And now you see the collider mesh here looks wrong. That does not look correct. One 742. Yeah, it's not correct for some reason. To be honest, I think this is where I'm like, okay, maybe we should start moving these things into some other location, and then when we end a scene, we simply just clear the map. And we have these just attached instead of trying to like clean up the map here. Yeah. To do. I'm gonna leave it as a to do because I don't have time to fix it now. Move this to some shared shape manager or the physics scene and simply clear it. At the end, clear it when we stop playing, well, when we stop simulating. Okay. Yeah, we're gonna have to do it that way. I may actually end up doing this tonight, so I might not do it on stream, or I may end up doing it on stream. I guess we'll see. So we are in fact doing that, but we just need to properly clean up shared shapes. Okay. So I'm gonna go ahead and push this, and then I'm gonna go ahead and end the stream, and it's this one. Yep. Yep. I'm not gonna go ahead and push those. Yeah, that's correct. Okay. What did we do? Well, added concept of simple and complex mesh colliders. All mesh collider components now have both a triangle complex and convex simple collider. So we fixed that up, which is good. I mean, that's kind of the major thing. We removed some old functions as well, but fixed bug with deserializing mesh colliders. That's basically the gist of it. So let's go ahead and push that. Okay, well, I'm gonna go ahead and end the stream here. I don't know if I'm gonna stream anything tomorrow. I might do that. I'm probably gonna be streaming a bit on, let's see, what is it today? It's Thursday, so probably Wednesday, either tomorrow or on Thursday. So but yeah, I guess I'll see you guys then, and until then, have a good day or evening. Bye bye.